All right. So yeah, Lee first and myself are going to talk about what seabed mining is, some of the potential effects it would have on our coasts, and what we're trying to do locally about it. I guess, Lee, do you want to touch a little bit on what Waterkeeper is up to?
Sure. Thanks, Liz. So I'm your Twin Harbors Waterkeeper. I'm based out in Cosmopolis and Aberdeen. And there are 350 waterkeepers all around the world and about 200 in the United States. And what we do is work for fishable, drinkable, swimmable water. The first waterkeeper in the world was the Hudson River Keeper. And that was in the early 1980s. So the movement is growing. And in fact, we just got a new affiliate program in South Sound that is trying to get started, that's associated with the Deschutes Estuary Restoration Team. So my area is Grays Harbor, the Chehalis Watershed, and the Willapa Bay Watershed, and all tributaries thereof. So my job as a waterkeeper is to advocate and protect those waters.
She does a heck of a job with it too. So my name is Liz Schotman. I am the Washington Regional Manager for Surfrider Foundation, which is a national nonprofit activist network that is dedicated to the protection and enjoyment of the world's ocean, waves, and beaches for all people. And so we do a lot with plastic pollution, both cleaning it up and trying to stop it from getting out into the environment. We do some water sampling and other clean water initiatives. And we also try to stop bad fossil fuel investment, such as offshore drilling and things like that. So we have 5 volunteer-run chapters here in Washington State, as well as 1 club up at Western Washington. So if you're interested in starting a Surfrider club after this talk, let me know. So seabed mining. So I like to start out this with a cool picture and some alarming quotes from some prominent conservation individuals. So we have this quote from Sylvia Earle, who is a renowned oceanographer and just all-around woman, badass and explorer. And she says, "What are we sacrificing by looking at the deep sea with dollar signs on the few tangible materials that we know are there? We haven't begun to truly explore the ocean before we have started aiming to exploit it." And then a more recent quote I found from Sir David Attenborough, who I have a total crush on. "The rush to mine this pristine and unexplored environment risks creating terrible impacts that cannot be reversed." And we'll talk more about what those impacts are a little later, but I like to start this presentation with these quotes because it really emphasizes the need for us to take a precautionary approach, because history is fraught with like hard lessons learned about destroying that which we do not know or understand. And the deep sea definitely qualifies as something that we do not really understand yet. We've explored about 0.01% of what's down there. And pretty much every deep sea adventure, we come back with like at least a few new species. And so that's why we're really pushing for this precautionary approach and trying to get ahead of this industry. So what is seabed mining? So it is the extraction of minerals and metals from the sea floor. And that sea floor can be anywhere from like right off our beaches and our low tide zones. And Lee's going to touch more about black sands and other resources that are very close to our own waters or in our own coasts, all the way out to the deep, deep ocean. I do want to differentiate it from another type of extraction of seafloor materials, which is called sand, gravel, and shell mining, or SGS. And if you go and like try to research this on like the federal website of, regulations on extracting seafloor materials, most of what's out there is going to be on sand, gravel, and shell mining. And that's for things like beach renourishment, dredging, soil island restoration, things like that. And, soil island fill. That's been around for decades. It has its own issues and environmental consequences that we're not really going to be speaking to in this presentation. We're going to be focusing more on deep sea extraction, so 200 meters or deeper, and some mineral-rich sands and other resources that are just those hard and industrial scale extraction of those hard materials. So when you start diving deep, pun intended, into the literature around seabed mining, you hear what are called like the main three sources of these minerals and metals that are down there. And they're kind of located in different areas of the ocean, and they kind of contain different suites of minerals. And I'll talk a little bit more in depth about each one of these in a second, but I wanted to point out where they are located. And so You have these manganese nodules, which are on what's called the abyssal plain, which are these just long, flat expanses in the deep sea, usually 4,000, 6,000 meters down. And they're just these like, not deserts, but they're just flat expanses of like sediment out in the deep sea. And then we also have what are called cobalt-rich crusts, which are located on top of seamounts, which are just underwater mountains. So those tend to be a little bit shallower because they're up on top of this underwater elevation. And then you have what's called seafloor massive sulfides, which are located still in pretty deep water, but along hydrothermal vents. So the manganese nodules are basically like these potato-sized lumps that are literally just sitting around out there on the abyssal plain. And so this is a picture of just endless silt, flat, silty area with these rocks. But those rocks are rich in things like cobalt and nickel and lithium and things that are really important for stuff like batteries and electronics. So a lot of really valuable resources in these rocks. And to harvest them, you basically just pick them up. You just pluck them right off the ocean floor, which on the spectrum of mining activities sounds pretty benign and not super destructive, but it's not without its consequences because you disrupt the sediment and create these sediment plumes, which Lee will touch on a little bit more. But you're also removing the only hard structure for animals to attach to. And so in this bottom left picture here, you can see that this is like a coral or a sponge that's attached to one of these nodules. And you can see all these other life forms that depend on that structure that just kind of grow off of it. And some of these species have evolved and are kind of endemic to these nodules. And so once you remove them, there's nothing hard for these organisms to attach to. And so you're basically eliminating that necessary habitat. And once it's gone, it's gone. These things grow at such a crazy slow rate, like talking like a millimeter every several thousand to a million years. And so it's permanently, gone once we remove it from the environment. So the cobalt-rich crusts are located on top of those seamounts, and they're often rich in, again, manganese, cobalt, and some other rare earth minerals. And if you're sort of, if you're riding around your submarine and you look down, the lower half of this picture is what you'd see. It just looks like rocks, basically a rocky sea floor. But if you were to take a cross section of that, you'll see this thick kind of black metal laced crust that can be anywhere from a centimeter to I think 6 or more inches thick. And so in order to extract that, you basically have to like plow it up, which is pretty destructive. It's basically like underwater mountaintop removal, which is very alarming because these seamounts are basically underwater hotspots. They're like oases in the desert. You get a lot of what's called upwelling, where you have these deep, oxygen-rich, nutrient-dense waters that will be flowing along in currents. They'll hit the walls of these seamounts, and you'll get what's called upwelling, which creates a lot of primary productivity, which drives the food chain. And so you have really important places for commercial fisheries, for example, and biodiversity, so like whales, sharks, sea turtles, all of those tend to congregate around these seamounts. And so removing these crusts is obviously going to be very damaging for those habitats, as well as all the species that depend on a healthy ecosystem around these seamounts. And when Lee and I first started giving this presentation last year, we were like, this is theoretical. This has not happened. But as Lee will talk a little bit more about, we have seen this happen for the first time late last year. A Japanese company in Japan's federal waters, where they did like the first ever extraction of a cobalt-rich crust, and we're waiting to see what the results of that are. But yeah, so this industry is starting to happen, and it's starting to take off. And finally, we have our seafloor massive sulfides. And so these are basically like metal-rich chimneys that build and kind of grow around hydrothermal vents. And so there's these hard mineral structures, and they're rich in silver and copper and gold and metals like that. And I'll go back to this picture because I like it better. But these are really amazing ecosystems because they have evolved in very different conditions than life that we're familiar with on Earth has evolved. So everything we interact with on a day-to-day basis gets its energy from the sun. Like the base of our food chain is photosynthetic, but these ecosystems are chemosynthetic. So the sun could die and they'd probably just keep doing their thing. They get all of the nutrients and heat that they need just coming out of the earth. So they're incredibly unique in all of the world. And we know very little about them because they're very hard to study because they're way down there. And some scientists think this is actually where life on Earth might have originated. So really cool creatures down there that are super unique, like 6-foot tube worms and fuzzy lobsters and just weird sci-fi like stuff. And so to harvest the metal from these sulfides is you have to kind of knock them over and smash them up and then bring those pieces to the surface for processing. So obviously that would be pretty destructive and ruin the day of all these creatures that are dependent on these hydrothermal vents. And I was recently kind of just nerding out on deep sea hydrothermal vent communities, as you do in your leisure time. And I found this thing called the sea pangolin, and I love land pangolin, so I was very intrigued. It's also called the Scaly-Foot snail. And this is just a good example of us barely knowing what's down there and the opportunities, not just in the preservation of really cool biodiversity, but this species has iron in its shell. Like it takes the minerals out of the water and like has an iron shell and these weird little iron things, these scaly things on its body. And what's really cool is that the middle layer of this like 3-layered shell is apparently able to absorb mechanical strain and energy and dissipate heat like crazily effectively. And so it has like a lot of like potential civilian and military protection applications. And so there's a lot of value to us as a species in learning and understanding about these deep sea communities that we know so little about. And this was actually the first species to be listed by the IUCN as endangered, specifically from seabed mining. And so we're starting to see, attention is drawn to this practice as well as these threatened deep sea communities. And I will let Lee take it from here.
Okay, so in Liz's slides, you saw quite a few big machines. So, they're developing these giant machines so they can harvest all these minerals. And so, some of the machines are like huge tractors or, the same kind of machines as are used for mining on land. And so to mine for manganese nodules and most of this stuff, the machine is going to be hard piped up to a giant dredge barge, like you can see in this graphic. So, they're going to vacuum this stuff up, pipe it up to a giant dredge barge, and then sort through it and keep what they want and then discard what they don't want. So that's called the dewatering plume. So this slurry of silt and mud and whatever they don't want is going to go back in the water, and it's going to cause a huge turbidity plume. And so that's going to make it really difficult for all kinds of creatures like whales and fish and everything else to navigate and find food. And this is just going to wreak havoc on aquatic life. And we don't know how far these plumes are going to travel. There's some studies that show that they'll go 10 to 100 kilometers. So these operations are going to be very noisy. The dewatering plume could affect the amount of light that comes through. It could be warm. The stuff that they pump out could have some amount of metals that are in the dewatering plume. This could affect the fishing industry and just a lot of unknowns here, and potentially really harmful side effects. So this is called the disc hull experiment, and this is one of the only documented disturbance studies that we have. This was conducted in 1989. A tractor-like device was used to plow across the bottom of a manganese nodule field, like that. When they started, it looked like the lower right-hand corner. This was done about 3,000 kilometers off the coast of Peru. So these slides, A, B, C, and D, show how the area recovered over time. And the photo in the upper right-hand corner was taken 26 years after the disturbance occurred, and the tracks are still there. previous studies of this area indicated that the microbial abundance and density had drastically changed. So this is one of the few studies that showed that damage from mining is likely irreversible. And this is really concerning because on Earth, you know, there's a lot of restoration activities going on. And, you know, after we've wrecked so many things on Earth, you know, we've been doing all kinds of, you know, sometimes major restoration, and we've gotten pretty good at it, but we have no idea how to do this, you know, absolutely no idea how to restore damage to the deep sea. So why is this whole issue coming up? So the primary driver to get these minerals is green technology, you know, car batteries, cell phones, wind turbines. And mining for these minerals on Earth is becoming increasingly difficult, both because of increased population and because of an expanding middle class that is driving urbanization and the need for renewable low carbon infrastructure. Also, the amount of easily mined minerals on Earth is declining. So deep seabed minerals are increasingly likely to make an important contribution to sustainable development, especially for small island developing countries that lack opportunities for economic development. Some of the major mining companies exploring seabed mining most of them are like a combination of a government and then one of these giant mining companies that has to do with building this equipment. And the names of some of them are Blue Water, Chatham Rock Phosphate, De Beers Marine in South Africa, Dredging International Group in Belgium, and Japan Oil, Gas, and Metals National Corporation. So we have this thing, we have a linear, you know, most forestry is a good example of a linear economy. We harvest trees, you know, we use the products from the wood, and in most cases, they're thrown away. You know, they're used over their lifespan, and then they're thrown away. In a circular economy, raw materials enter a cycle where their value is maintained throughout its life cycle. So when you're finished with something, it can loop back up the chain to be reused again. So, you know, if we all try to practice or do what we can to promote a circular economy, such as recycling. So, you know, we all know that metal is recyclable. It's expensive. It requires a lot of transportation, but it's still much better to recycle than it is to try to do more mining. One example of a circular economy is the German car manufacturer BMW. And in Germany, there is a legal requirement to recycle end-of-life vehicles, components, and materials with a quota of 85% for reuse and recycling. So, you know, we need that kind of thing here. Why now? You know, because there's such an emphasis on electronics, batteries, and green technologies. So, you know, and we dispose of so much. In 2019, the world generated 53 million tons of e-waste. That's equivalent to almost 150 Empire State Buildings. So the potential value of this recycled minerals in this amount of e-waste is just a mind-boggling amount and worth a lot of money. So we need to improve these practices in order to prevent mining the deep. So we all love maps, right? This is a cool map. it shows, so the white area is the exclusive economic zone of these countries. It goes to 200 miles out. And so all countries that have a shoreline have an exclusive economic zone. And this map also shows where some of the deep sea's resources are found. And let's see here. So I mentioned the disc call experiment off the coast of Peru. You can see where that was located. And then Solwara 1 right in the middle there. It was the first proposed deep sea mine in the Pacific, in the Bismarck Sea, approximately 30 kilometers off the coast of Papua New Guinea. They had planned to mine seafloor massive sulfides, those rich hydrothermal vents formed by plumes of hot, acidic, mineral-rich water on the seafloor. But the people of Papua New Guinea, who rely on a lot of, there's fishing is really important there. They protested that and they called for a full ban of seabed mining. So now a 10-year moratorium on seabed mining has been declared to allow proper scientific research. So that's good news. And there's still an upheaval in Papua New Guinea about this, because they want to make sure that it's not just a 10-year ban, but it's not going to happen. And then, like Liz mentioned, off the coast of Japan, this is where the first successful excavation of cobalt-rich seabed in the deep ocean happened. So the prior research indicated the possibility of a significant amount of cobalt and nickel, which are essential ingredients for batteries. So we know this has happened. I haven't actually got my hands on the results or how successful this was. Yeah, off the coast of Namibia, the De Beers Group, which is just an enormous mining company, they mine diamonds off that area, and they've been doing it for a long time. Yeah, okay. And then in Washington, this is a map of the Chehalis watershed. The Chehalis, I work on a lot of issues in the Chehalis watershed. It's the largest watershed that's completely within the state of Washington's boundaries. And so they're back in the 1960s, and even earlier than that, there was a search and exploration for mineral-rich black sands in and around Cape Disappointment and at the mouth of the Columbia River and in Grays Harbor. So there was a serious attempt. Leases were acquired. The government agency that can grant leases is the Department of Natural Resources. So leases were granted, and there was a serious attempt to produce titanium and iron products by a company called Washington Mineral Products in 1967. The operation failed and then closed. And then the only other mineral-related activity conducted in state waters has been a continued search for the development of titanium and iron-rich black sands in the same area. So this is a really valuable material that's right on our shore and an hour from Olympia. And so although this really hasn't happened yet, it's very concerning. This is a map that shows the Washington coast and Puget Sound and the Salish Sea, and it shows the pink area is Washington state water. So this is the part of the ocean and the Salish Sea that is regulated by the state of Washington, and it's from the extreme high tide to 3 miles offshore. And you can see the little green dots on here. That's where there has been some mineral exploration, and we don't know exactly what they found, but we're working to find that out. And so you can see the marine sanctuary is out there. It's the hatched area, and so, you know, we got involved in this whole issue when we partnered with the Pew Charitable Trusts. They have a campaign that's been running for a while. They've been working with the state of California to try to ban seabed mining in the state of California. And now they're working with us to try to ban it in the state of Washington. Oregon banned it in 1991. So there is a bill in the legislature now, Senate Bill 1541, and we are so excited about that. I'll talk about that in a minute here. And I sent Avery like an action sheet, which hopefully she'll send out, and I'll talk a little bit more about that in a minute. But before we do that, here's a really cool picture of what a manganese nodule looks like close up. They contain mainly manganese, but also iron, nickel, copper, titanium, and cobalt. They're of interest because they contain greater amounts of some metals than are found in today's economically mineable deposits on land. It is assumed that the worldwide manganese nodule occurrences contain significantly more manganese than reserves on land. Well, you got to hear me say that twice, so sorry about that. And then I don't know if any of you have actually been to see a mine. I've seen a couple mines close up, like deep coal mines, and looked at the equipment running these mines, and you know, it had a long-term effect on me. And the pollution from mining is in many countries of the world, you know, especially South Africa, India, China, Australia, Africa, it's a huge amount of pollution that comes from mining. And you know, in the United States, at least the mines that are operating have permits. You know, they have permits, probably several permits, but you know, if they pollute water, they have to have a certain kind of permit that regulates the discharge. So even though, you know, there still is terrible pollution of rivers and streams from mines, but at least they have permits, and occasionally an inspector will go out and, you know, make them put best management practices in to try to prevent pollution. But, you know, if we were to do this kind of devastating activity, you know, hundreds of meters under the sea, we would, you know, we would never be able to see it. Who's going to monitor that? Who's going to know, you know, how much they did or what they did? So, you know, that's a really, that's something we really want to not have happen. And yeah, so that kind of wraps up my little part. I sent 5 things you can do to Avery, so maybe you all have it. We've got a business sign-on letter. We've got a nonprofit sign-on letter. You can go to the Senate Bill 5145 bill page to, you know, register as a pro or con. You can kind of track this. It's close to being out of the Senate. I think it has one more committee to go through in the Senate and the state Senate, and then it goes to the House. You can call your legislators. If if anyone has a burning desire to meet with your legislators, we're actually starting to organize a lobby day on the first week of March. And we're looking for a few more people who would like to participate in just virtual meetings. And we would help out by giving you talking points. And we just want, I'm sure you have some questions, and Liz is really good at answering questions. So, and do stay in touch with us. I'd be happy to hear from you. We have a newsletter. We'd love to add your name to it. So feel free to contact me, and thank you so much.